Hi friends, in this video I will explain most important and easy topic electrical and electronic measuring instrument. Here the term measuring refers to the comparison of known quantities with unknown quantities. That means I will say an example. If I went to a shop and asking a shopkeeper to give 1 kg of onions, what the shopkeeper is do compares that 1 kg of onions with the known 1 kg weights. That processing is nothing but measuring. For that process, used instruments are known as measuring instruments. The use of the measuring instruments is for measuring both electrical and mechanical quantities. The measuring instruments are mainly classified into 3 types. First one is electrical measuring instrument, and second one is electronic measuring instrument, and then third one is mechanical measuring instruments. Here, mechanical measuring instruments gives the response at static conditions only. They don't provide any output at dynamic conditions. And electronic measuring instruments gives their response very quickly when compared to remaining both measuring instruments. And mechanical measuring instruments gives their output in mechanical quantities only. Now I will say about electrical measuring instruments. The definition of electrical measuring instruments are the instrument which measures the quantities of electrical is known as electrical measuring instruments. That means measuring of resistance, voltage, current and power, etc. These measured instruments are known as electrical measuring instruments. Here we can observe for calculating the resistance we can use the ohm meter. For calculating voltage we can use voltmeter. For calculating current we can use ammeter, etc. These instruments are known as electrical measuring instruments. Now I will say about range extension of ammeter. This is the one of the topic for AP grama sachivalayam digital assistant. First topic. First I will explain the definition of ammeter. An ammeter is a measuring instrument used to measure current flowing through the circuit. And the range of an ammeter is microamperes, milliamperes and sometimes nanoamperes also. The range extension of ammeter means generally we observe so many ammeters. At the labs we can observe the ammeters whose range is 0 to 50 milliamperes. And some ammeters range is 0 to 100 milliamperes. And we can observe the maximum range of an ammeters in our daily life is 0 to 500 milliamperes. If I want to measure the current beyond these ranges, these ammeters can't use for that process. That's why we want to increase the range of ammeters. This process can be done by using the method named as shunt method. The name itself indicates the shunt, in parallel adding some resistance to the ammeter. We know the formula V equal to IR. From this we can measure the current is equal to V by R. Our aim is increasing the range of ammeter. So I want to increase the calculation of current to the ammeter. I want to increase the current, that's why I should decrease the resistance. That means here I is inversely proportional to R. I want to increase, if I increase the range of ammeter, then the resistance value should be decreases. Now we have to calculate the how much range if we add parallel to this meter, then the meter's range is increases. Here we know in parallel the voltage is common, so the voltage passed here and the voltage here both are same. That's why we know that the resistance voltage V is equal to ISH into RSH is equal to voltage flowing through this meter IM into RM. We have to calculate the shunt resistance here. Here RSH is equal to IM RM divided by ISH. Here we know the current I is equal to ISH plus IM. From this ISH is equal to I minus IM. So shunt resistance RSH is equal to IM RM divided by I minus Im. RSH is equal to, here I am getting the common of Im term, Im into divided by Im minus 1. Here Im gets cancelled. The shunt resistance RSH is equal to Rm divided by, here m is equal, the constant m is equal to I divided by Im. So m minus 1. This is the shunt resistance. This much of resistance if I add parallel to the ammeter, then I can increase the range of ammeter. I will say once more, this much of resistance added in parallel to the ammeter, then you can increase the range of ammeter. There is also a chance to asking some problems in this topic. I will say explain. Here is the problem. There is a chance to ask it at exams. A moving coil meter having an internal resistance Rm is equal to 12 ohms and full scale deflection current, that means meter current, is equal to 20 milliamperes. Design a multi-range ammeter and calculate the shunt resistance. What they asked, calculate the shunt resistance, that means RSH we want to calculate. Here is the shunt resistance of the resistor and there is a